Okay, good morning. So, am I audible?
Yes, sir.
Okay, fine. So, today we shall discuss some more problems on resultant of non-concurrent force system. Now, last class we have discussed this problem. And today we shall discuss some more problems on resultant of non-concurrent forces. Now, here you have a rectangular plate, and it is subjected to forces at point A, point B, point C, and at point D. And you are required to find the magnitude, direction, and also the position of the resultant. Here, they determine the magnitude, direction of the resultant for the force system shown in figure. Locate the resultant force with respect to point D. So that is here, the resultant of all the forces is required at this point. That means required to find the magnitude, direction, and position of the resultant with respect to point D. Now, so first always you can select the reference axis right over here, and here the forces are 4 kilonewton, and here you can do one thing. So instead of selecting the reference axis about point A, so since the position and direction and magnitude is required at point D, so you can select the reference axis right over here, x and y, and now point here you have a force of 5 kilonewton. So here the angle is not given, the slope of the line is given. So thereby you can find this angle. That is by using the tan relation, tan theta is equal to 1 by 2, that is 0.5. So tan inverse 0.5, you can find this angle. So if you find this angle, so you will get this angle, alternate angle with respect to x-axis. So what is tan inverse 0.5? How much is the angle? And in 110. So find out this angle theta. So on the alternate angle theta, this will be also theta with respect to x-axis. That is tan inverse 0.5. How much it is?
26.5.
Okay, this angle is 26.56. Okay, now first select the reference axis and calculate sigma f of x. So sigma f of x, the forces which are parallel to x-axis. So one by one in the clockwise direction we should move. So we have found this angle, that is its cos component is minus 5 cos 26.56. Sigma f of x is equal to minus 5 cos 26.56 plus 4. You can see here this towards the positive axis plus 4. So hence sigma f of x is equal to minus 5 cos 26.56 plus 4, and sigma f of y will be minus 5 sine 26.56 minus 6. So 6 kilonewton forces acting in the downward direction. So we'll get the values of sigma f of x and sigma f of y. Now you can find the magnitude of the resultant. R is equal to square root of sigma f of x square plus sigma f of y square. Thereby you get the magnitude of the resultant, whatever the value that you get sigma f of x. Let us check. So here sigma f of x is 4 minus 5 cos 26.56. So it works out to be 0.472. So here the units have not been written. So don't forget to mention the units. It is 0.472 kilonewton, and sigma f of y is also negative. It is 8.236 kilonewton. So hence the resultant acts in the third quadrant, because sigma f of x is also negative, sigma f of y is also negative. So thereby you get the magnitude of the resultant, that happens to be 8.249 kilonewton, and direction of the resultant, so tan alpha, so that is works out to be 86.72. So the resultant acts in the third quadrant, which makes an angle 86.72 degree with respect to x-axis. Now you need the position of the resultant with respect to point O, correct? So sorry, point D. So now take the moment of all these forces with respect to point D. So now let us start from this. So its x component is 5 cos 26.56. It is in line with line AD. So hence the perpendicular distance is 0. And for the vertical component at this point, for this force, it is 5 sine 26.56, 5 sine 26.56. And if you consider the moment, it creates an anti-clockwise movement with respect to this point. So hence it is minus 5 sine 26.56 into the distance is 2 meters. So for the vertical component of this force, it is 5 sine 26.56. It creates an anti-clockwise movement. So minus 5 sine 26.56 into 2. Now 4 kilonewton. Now if you extend the line of action of this force, it is acting like this. So it creates a clockwise movement with respect to this point. So hence 4 into the perpendicular distance is 1.2. So sigma md, you can take it as sigma md, since you are considering the moment of all the forces with respect to point D. So sigma md is equal to minus 5 sine 26.56 into 2 plus 4 into 1.2, 4 into 1.2. And now you can see here at point D already you have an existing moment. You can see this arc. At point D, it is subjected to an existing moment of 8 kilonewton meter. So directly consider its value without multiplying with the distance, because already it's an existing moment. So here it is in the anti-clockwise direction. So hence sigma md is equal to minus 5 sine 26.56 into 2 plus 4 into 1.2 minus 8. So now let us check the moment of the resultant. Sigma md 4 into 1.2 minus 5 sine 26.5 into 2 minus 8. And again one more, sorry, we have not taken this. So this is acting in the downward direction like this, and it also creates an anti-clockwise movement like this. So minus 6 into the perpendicular distance is this one, 1 meter. So sigma md is equal to minus 5 sine 26.56 into 2 plus 4 into 1.2 minus 6 into 1 minus 8. So now you can check. So the sum of moments is negative. That means you can, instead of putting negative sign, you can put this arc like this, since the sum of moment is 13.671 kilonewton meter, it is minus. So like this you can present. Now we want the position of the resultant D, that is sigma md, or whatever the moment that you have taken, if divided by the resultant value, it is about 1.657 meters. So then you can also find the x-intercept and y-intercept. So in this problem, he has not asked to find the x-intercept and y-intercept. Anyway, you can also find, no problem. Since you know sigma m, so x-intercept is nothing but sigma m divided by sigma f of y, and y-intercept is equal to sigma m divided by sigma f of x. So next you have one more problem here. So here you have a rectangular plate, sorry, square, it's almost square plate, 4 meters by 4 meter, and at point A it is subjected to 100 Newton. And you can call this point as, say, somewhere, you can call this point as E. At this point it is a 200 Newton force is acting, and at point C you have a 100 Newton force, and at point D you have a force 100 root 2 Newton. So determine the magnitude, direction, and position of the resultant force with reference to point A. So you are required to find with respect to point A for the non-coplanar force system shown below in figure. So now select the reference axis about point A. Next, find the sum of horizontal components. Sum of horizontal components, in our case, minus 100 plus 100, minus 100 plus 100 plus 100 root 2 cos 45, 100 root 2 cos 45. If you resolve this, its x component is plus 100 root 2 cos 45. So sigma f of x is minus 100 plus 100 plus 100 root 2 cos 45. So sigma f of y is plus 200 minus 100 root 2 sine 45, because only two vertical forces you have. So thereby you get the values of sigma f of x and sigma f of y. Then you can find the magnitude of the resultant. R is equal to square root of sigma f of x square and sigma f of y square. So once you find the magnitude of the resultant, then you can find the direction of the result. So this is the sequence you need to follow. So always in any problem, you start with the reference axis. Once you select the suitable reference axis, then find the sum of its horizontal component, then sum of the vertical components. Next step is find the magnitude of the resultant. Once magnitude of the resultant is got, so find the direction of the resultant. Then you take the moment of all the forces with respect to any given point, correct? Any given point. Then equate the moment, sum of the moments is equal to the moment of the resultant into the position of the resultant. Thereby you get the position of the resultant. Once you get the position of the resultant, then comfortably you can find the x and y intercept. So now you know how to find. So you have any problem in finding sigma f of x and sigma f of y? Are you clear with the concept? Hello? Hello? Yes or no? I hope the concept is clear. Now let us check. So sigma f of x is, now again, here some mistake is there. You can see here it is plus 100 root 2 cos 45. So he has put minus, it's wrong. So sigma f of x is, because if you resolve, its x component is plus 102 cos 45 plus 100. This is 100, okay. This is minus 100. So there is a printing mistake here. So sigma f of y, it is correct. Minus 100 root 2 sin 45 plus 200. It happens to be 100 Newton. So I think this value will change. So always there will be some mistakes due to printing mistakes. So always follow the basics, right? So once you, I think this will be different, and obviously the resultant value will be also different, and the angle of inclination will also be different. Now anyway, so now let us find the moment of all the forces with respect to point A. So since 100 Newton force, it is acting along line AD, the perpendicular distance is 0, we can neglect this. So next you have 200 Newton force, and if you consider the moment about this point, so it is acting like this, correct? So force into perpendicular distance 2 meters. So it is creating an anti-clockwise movement with respect to point A. So minus 200 into 2. Then you have 100 Newton force. It is acting like this, correct? So force into the perpendicular distance is, height is 4 meters. So it creates a clockwise movement. So minus 200 into 2 plus 100 into 4. And for the cos component, it is acting along line AD, perpendicular distance is 0. And for the sine component, that is 100 root 2 sine 45, the perpendicular distance being 4 meters. So it is also causing a clockwise movement. You can say force into the perpendicular distance. Now let us check whether the moment that has taken is correct or not. So 100 root 2 sine 45 into 4 plus 100 into 4 minus is 200. 200 into 2. So here again you can see one more printing mistake. Instead of 200, he has taken 208 into 2. So whatever may be the case, so always follow the basics. So you get the position of the sum of the moments. Then once you get the sum of the moments, then comfortably you can calculate the value of D, that is the position of the resultant. So you will get the sum value, because here some mistakes is there. So please correct this, okay? Then find x and y intercept. So every problem, the same procedure you need to follow. First select the reference axis, then be careful while calculating the sigma f of x and sigma f of y. Then you can find the magnitude of the resultant, then the direction of the resultant, then the position of the resultant. Then you can find x and y intercept. So like this, we can solve any number of problems. Again, one more problem here we have. Find the magnitude, direction, and distance of the resultant from point A. So you are required to find the magnitude, direction, and position of the resultant with respect to this point. So first you select the reference axis, x and y, about this point. Then find the sum of x component. So now let us start one by one. So minus 75 cos 45, minus 75 cos 45. Now you can see here this force 45 kilonewton. It is making an angle 30 degree with respect to y-axis, and it is making an angle 60 degree with respect to x-axis. Either you can resolve with respect to y or with respect to x-axis. So sigma f of x is minus 75 cos 45 plus 45 sin 30, 45 sin 30 or 45 cos 60, 45 cos 60. Either because I have selected with reference to x-axis. So minus 75 cos 45 plus 45 sin 30 or 45 cos 60. Now again here it is making an angle 60 degree with respect to y-axis. Obviously it makes an angle 30 degree with respect to x-axis. So sigma f of x all put together minus 75 cos 45 plus 45 cos 60 plus 60 cos 30 or 60 sin 60. So thereby we'll get the values of sigma f of x. Now sigma f of y. Sigma f of y minus 75 sin 45 minus 75 sin 45. Again here it is minus 45 sin 60 or minus 45 cos 30. Okay, minus 45 sin 60. Again for this one it is plus 60 sin 30 plus 60 sin 30 or plus 60 cos 60 cos 60. So either you can resolve with respect to x or y axis. So you'll get sigma f of x. Once again I will tell sigma f of x will be minus 75 cos 45 plus 45 cos 60 plus 60 cos 30. Sigma f of y minus 75 sin 45 minus 45 sin 60 plus 60 sin 30. 60 sin 30. So thereby you'll get the values of sigma f of x and sigma f of y. Then you can find the magnitude of the resultant. Now let us check whether he has taken it correctly. Sigma f of x 45 sin 30. So here you can see he has resolved with respect to y-axis, or it is 45 sin 30 or 45 cos 60 plus 60 sin 60 or 60 cos 30. 60 cos 30 minus 75 cos 45. So it works out to be 21.42. So here he has not mentioned the appropriate units. So always better to mention the appropriate units, kilonewton. And sigma f of y minus 45 cos 30 minus 45 cos 30. Yes, this one. Either it is minus 45 cos 30 or minus 45 sin 60 plus 60 cos 60 or 60 sin 30 minus 75 sin 45. So it works out to be minus 62.004 kilonewton. So sigma f of x is positive and sigma f of y is negative. So the resultant lies in the fourth quadrant. So once you get the sigma f of x and f of y, you can comfortably calculate the magnitude of the resultant as 65.602 kilonewton. So then you can find the direction of the resultant. It was to be 70.93 degree with respect to x-axis. So then you can find the position of the resultant. That is nothing but sigma. You have to consider the moment with respect to point A. Now let us find the moment of all the forces with respect to point A. So sigma MA, you can call it as sigma MA, 1 by 1 we shall deal. So for the horizontal component of this force, that is minus 75 cos 45, correct? This is acting like this. So 75 cos 45 and the height is being 3 meter, it creates an anti-clockwise movement. So hence minus 75 cos 45 into 3, minus 75 cos 45 into 3. Then you can see here at this point you have a clockwise movement of magnitude 100 kilonewton meter. So since it is clockwise, directly consider its value. Don't multiply with the distance, directly consider the value. So sigma MA will be minus 75 cos 45 into 3 plus 100. Now here the vertical horizontal component of this force is 45 cos 60. So if you project back, it is acting like this. So 45 cos 60 is creating a clockwise movement, correct? It is creating a clockwise movement at about this point. So hence plus 45 cos 60 into the perpendicular distance is 3. And for the vertical component of this force, that is, it is acting in the downward direction, 45 sin 60, it is creating a clockwise movement about point A. So 45 sin 60, it is acting like this downwards, right? Downwards, and it is creating a clockwise movement and the perpendicular distance is 2 meters. So 45 sine 60 into 2 meters. Next, if you resolve this force, its vertical component is 60 sine 30 and 60 cos 60. Sorry, it's 60 cos 30 and 60 sine 30. For the 60 cos 60, 30, its perpendicular distance is 0. So hence moment is 0. And for the 60 sine 30, it is acting like this, upward direction, and it creates an anti-clockwise movement with respect to this point, and the perpendicular distance is 2 meters. So hence sigma MUA will be MA minus 75 cos 45 into 3 plus 100 plus 45 cos 60 into 3, 45 cos 60 into 3 minus 45 sine 60 into 2 minus 60 sine 30 into 60 sine 30 into 2. So now let us check. Sigma MA minus 75 cos 41 into 3 minus 60 cos 60 into 2. So here he has taken it as 60 cos 60, correct? 60 cos 60 into 2. So anyway, either you can resolve with respect to x-axis or y-axis. So here, this moment he has directly taken, considering its direction, it is 100 Newton, 100 kilonewton. So don't multiply with the distance. So thereby you get the sum of moments as 26.343 kilonewton meter. Then once you get the sum of moments, you can find the position of the resultant D, that is nothing but sigma MA divided by the resultant value. Then you can find the x and y intercept. Is it okay? Are you following? You people are following the concept? Anyone has having any doubts? You can ask freely. Hello? Is it okay?
Yes, sir.
Because we have solved so many problems, correct? Till date on resultant of non-concurrent forces. ಯಾರಿಗಾದ್ರೂ ಒಂದು ಸಮಸ್ಯೆ ಆಗ್ತಾ ಇದೆಯಾ, ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ವಾ? You can ask freely, okay? No hesitation. Okay, fine. I hope all understood. So like this also you can have many problems like this. So please, anyway, I have shared this notes to all of you. So just go through the problem. There are some printing mistakes. So always go with the basics. There won't be any problem by you. So again, you have many problems. Here, these types of problems we have already discussed in the previous class. So here it is an exercise problem. Try this problem. So find the magnitude of the resultant, the direction of the resultant, and the x-intercept, and also the position of the resultant. Again, here you have one more problem like this. So here the resultant, just check it. Resultant is 25 kilonewton, theta is 45 degree, and the x-intercept is 62.1 centimeters. It is going out of the figure. Okay, anyway. So these types of problems we already solved. Now here you have a exercise problem. So wherein it is a dam structure. It is a dam structure. So you know what is a dam or a reservoir, which is mainly constructed to store water on the upstream side, and the same water can be utilized for various purposes. Now it is a two-dimensional figure. Now here the various forces are acting at different locations. Now let us call this point as, say, A. We can call this point as B, point C, point D, point E, point F, okay, and point G. Okay. Now the distances, corresponding distances are given here. Now at point say B, the 600 Newton force is acting, correct? And at this point, the 200 Newton force is acting in the upward direction. And at this point, a 500 kilonewton force is acting. And at this point, it is subjected to a force of 2000 kilonewton. So various forces to be considered for the stability analysis of a dam are as shown in figure. The dam is safe if the resultant passes through the middle third of the base. Now here, this is the base of the dam. So the resultant should pass through the middle third, one third and two thirds. So it should be, suppose it is, if it is one third, so 7 divided by 3. 7 divided by 3 is, I hope it is 2 point something, 2.5 meters. And if it is two third, it is 14 divided by 3. So 14 divided by 3 is roughly about 4 point something. So for the stability analysis of the dam, whatever the resultant that you get, it should be within, it should cut within the 1/3 base width of the dam. Now let us check what will be the magnitude of this resultant. Now, so consider the reference axis first, right over here. Consider the reference axis, x and y. Now we shall find sigma f of x, sigma f of x. So in this case, we have only 600 kilonewton force, which is horizontal. That is, sigma f of x will be, so you write down the problem, sigma f of x will be 600 kilonewton. Because since you have only a horizontal force of 600 kilonewton. So sigma f of x will be 600 kilonewton. Next is sigma f of y. So here you have 200 acting in the upward direction plus 200 minus 500 minus 2000. That is 2500 minus 2500 minus 2 plus 200 is totally minus 2300 kilonewton. So sigma f of x is 600 kilonewton. Sigma f of y will be minus 2300 kilonewton. So you can find out the magnitude of the resultant. R is equal to square root of 600 square plus minus 2300 square. So thereby you will get the magnitude of the resultant. Now let us check whether he has given the answers, I think. No, here he has not. So please tell me what is the value of the resultant. Sigma f of x is plus 600 kilonewton and sigma f of y is minus 2300 kilonewton. So square it. What is the value of the resultant you get?
2376.97 Newton.
Very fine. 2000, 2003?
376.
76 point something kilonewton. Okay. Now you got the magnitude of the resultant. Now the direction of the resultant is sigma f of y divided by sigma f of x. That is, theta is tan inverse sigma f of y is 2300 divided by 600. Correct? So what is the direction of the resultant? Theta or alpha? It is sigma f of y by sigma f of x. How much it is? It is about 73 something.
75.379.
Okay, 75.379. So the resultant acts in the fourth quadrant because sigma f of x is positive and sigma f of y is negative, and the resultant acts in the fourth quadrant like this. Correct? It is acting like this, and it makes an angle alpha with respect to the x-axis. It happens to be 75 point something. Okay, so you found the magnitude of the resultant and the direction of the resultant. Now we need to find the position of the resultant. Correct? So now consider the moment of all the forces with respect to this point. So let us call this point as A. So sigma MA is equal to 600 into 4. Correct? This height is 4, and this will create a clockwise movement. 600 into 4 minus, you can see here, this is 200 Newton force. It is acting like this. Correct? So it creates an anti-clockwise movement. So the distance is 4 meters. So sigma MA is 600 into 4 minus 200 into 4 minus 2. And this one, 500 Newton force, and the perpendicular distance is 5 meters. It creates a clockwise movement. 500 into 5. 500 into 5. Again, this 2000 kilonewton force is also acting downwards like this, and the perpendicular distance is 6 meters. So finally, sigma MA is equal to 600 into 4 minus 200 into 4 plus 500 into 5 plus 2000 into 6. So what is the value? final sigma MA.
$8,000.
How much? How much? Pardon? So 5 is 2,500, and this is 2,000 into 6 and 12,000. 12,000 plus
16,100.
16,000.
100.
100. Okay. So sigma MA is 16,100. So that divided by the resultant value. You got the resultant value as 2,700 something. So tell me the position of the resultant D. That is sigma MA divided by resultant.
6.77.
Okay, 6.77. Now you can see it is acting beyond 1/3. Correct? Beyond 1/3 is nothing but the base of the dam is 7 meter. So 7 divided by 3 is about 2.5 meter. It should have been here. It is acting here. So it is unstable. So in the stability analysis, whenever we make the stability analysis, so the dam has to be safe. You can see dam is safe if the x-intercept is between 1/3 and 2/3 of the base. And also you can find the x-intercept. Anyway, the resultant is the position of the resultant with respect to point A is that is 6 meters something, correct? 6 point something, correct? How much it is? Sigma MA by R. How much you got? 6.7. 6.7. Okay, it is somewhere, and the resultant is somewhere here. Now let us find x-intercept. So x-intercept is nothing but sigma MA is how much? 16,000, correct? 16,000 something divided by sigma f of y. How much it is? We want the x-intercept of the resultant. How much it is? X-intercept. Sigma MA. Can you hear me? Okay. So okay, I will continue the class in the tomorrow. So again, we have one more problem like this. It's also a typical dam structure. So tomorrow we shall take up these two problems. So I'll be ending this session. So how much you got? X-intercept, anyone?
-7.
-7 you got. No, don't consider negative value. Sigma f of y, it may be negative. So the sum of moment, sigma MA divided by sigma f of y. I think it is 16,000 something you got moment. Correct? How much is the moment value?
16,100.
Okay, 16,100. Correct. Sigma f of y is 2,300. No, it cannot be minus. 16,100 divided by 2,300. How much it is?
7.
Huh? Okay. Sure.
2.6.
16,100 divided by 2,300.
2.
Huh? Oh, how come it is? 16,100 divided by 2,300. It is 7, correct?
Yes, sir.
Okay, okay. It is going beyond. It is not safe. So whatever may be the case, don't worry about the analysis part. So we are much interested in finding the magnitude, direction, and position of the result. Okay, I'll be ending the class for today. So we shall meet tomorrow at 10:45. So again, we shall discuss some more problems. One more problem of similar kind. So anyway, so please mark your attendance if you are not marked. I will be ending the session. Thank you so much. Shall I stop the session?